Question 1. As illustrated by a recent field service call, Technician Laura is tasked with brazing a copper liquid line to a steel receiver inlet in a rooftop unit. The weather is humid and wind gusts are present. She prepares the copper and steel pipe ends, selects an appropriate flux, and prepares to braze with an oxyacetylene torch. Which of the following actions is most critical to ensure a successful leak-free joint under these conditions? A. Use a high silver content brazing alloy to bridge the dissimilar metals effectively. B. Position the steel side above the copper to prevent capillary failure. C. Preheat both materials evenly with direct flame to the joint. D. Apply excess flux to compensate for wind-related oxidation. Answer. Correct answer A. Explanation. When brazing copper to steel, dissimilar metal bonding requires a high silver content filler alloy, typically with at least 15% silver, to accommodate differences in thermal expansion and oxidation behavior. Flux alone cannot overcome metallurgical incompatibility, and even preheating or incorrect joint orientation may lead to cracking, but the alloy choice is foundational. This is supported by ORSA Point 8. FACNA brazing guidelines for dissimilar HVAC metals. Question 2. In terms of selecting machine parameters, Technician Darnell needs to perform a vertical uphill small weld on a 3/8-inch mild steel pipe. He selects C, electrodes, and adjusts amperage and arc force accordingly. Which parameter adjustment is most likely to improve his bead shape and penetration? A. Reduce amperage to avoid excessive penetration and undercut. B. Increase travel speed while maintaining current arc length. C. Increase arc force. Dig setting to stabilize the arc and reduce slag inclusions. D. Use a wider weave pattern to control puddle size. Answer. Correct answer. C. Explanation. The arc force or dig setting boosts voltage during low arc length, stabilizing the arc and preventing stubbing, especially helpful for vertical uphill welds using cellulosic rods. E. Increasing arc force enhances root penetration and slag control. Per Lincoln Electric and ORS D.1, fine-tuning arc characteristics is essential for positional welds on medium-gauge steel. Question 3. Considering the evidence, a team installs a high-pressure suction line in a commercial refrigeration system using GMOR. After welding, they pressurize the line with nitrogen to 350 psi. A pressure drop of 10 psi is observed over 30 minutes. What should they do next? A. Add more nitrogen and retest it. A higher pressure. B. Apply soap solution externally to identify the leak. C. Conduct a vacuum decay test instead for better accuracy. D. Immediately evacuate and charge the system assuming temperature fluctuation. Answer. Correct answer B. Explanation. A drop in nitrogen pressure typically indicates a leak. Applying a soap solution is a non-destructive industry standard method for leak detection. Vacuum testing is not suitable when the system is already pressurized. Pressure testing guidelines from ASHRAE Standard 15 and EAR Bulletin No. 110 support this method before proceeding to evacuation. Question 4. From a practical standpoint, which of the following conditions observed during a visual inspection of a completed overhead weld on a steel pipe would require the weld to be rejected under ORS standards? A. Slight discoloration around the toe of the weld. B. Undercut measuring 1, 16-inch deep over a 2-inch length. C. Uniform ripples with mild convexity across the bead. D. Minor porosity limited to the weld face. Answer. Correct answer B. Explanation. Undercut exceeding 1/32 inches unacceptable. Per ORS D.1 Table 6.1, especially on pressure piping, a 1/16-inch undercut over 2 inches significantly weakens the weld integrity, especially in HVACR high-pressure applications. Discoloration or slight porosity might be permissible depending on location and extent, but this undercut violates key acceptance criteria. Question 5. With respect to HVACR field prep, Technician Henry is tasked with preparing steel pipe ends for a DO route pass on a chilled water return line. Which step is most critical before welding to ensure proper fusion and minimal contamination? A. Apply anti-spatter spray to the inside of the pipe. B. Mechanically grind both pipe ends to a mirror finish. C. Wipe all surfaces with acetone to remove oils and debris. D. Preheat pipe ends to 400 degrees to reduce oxidation. Answer. Correct answer C. Explanation. Solvent cleaning, especially with acetone, is essential to remove hydrocarbons that can cause porosity or inclusions in GTOR. Mirror polishing is unnecessary and can embed contaminants. Preheating is only required for thicker sections or special alloys. Was D.2 and CGA G4.1 emphasize surface cleanliness in HVACR orbital and manual welding. Question 6. Given the circumstances, Annika is cutting Schedule 80 copper pipe for a high-temperature refrigeration circuit. She notices slight ovality at the ends due to prior clamping. What is the best action before fitting and brazing? A. Proceed with brazing if the fit-up gap is equals 1/8 inch. B. Ream and debur the interior and continue fitting. C. Use resizing tool or swaging device to restore roundness. D. Compensate with more filler metal during the braze. Answer. Correct answer, C. Explanation. Brazed joints depend on uniform capillary spacing, typically 0.2 to 0.5. Ovality disrupts flow and joint strength. Using swaging or resizing tool restores roundness, enabling proper fit. SB.22 and SMACR HVAC duct construction standard stress roundness and tight tolerances for pressure applications. Question 7. To illustrate this point, which of the following is the most probable root cause of linear porosity along a fillet weld on aluminum piping when using GTOR, i.e. excessive arc length during weld progression? B. Inadequate shield and gas coverage due to wind. C. High-frequency arc start used on clean material. D. Use of zirconated tungsten instead of pure tungsten. Answer. Correct answer, B. Explanation. Aluminum is highly reactive with oxygen and requires consistent shielding from argon gas. Outdoor wind disrupts coverage, leading to oxidation and porosity. Arc start method or tungsten type influences arc stability, not porosity formation. Was D.2 an Aluminum Association guidelines one of wind shielding failures in aluminum GTOR? Question 8. In a modern context of job site safety, Julian is transporting oxygen and acetylene tanks across a rooftop to begin a brazing job. Which of the following practices violates OSHA and CGA guidelines? A. Using a cylinder cart with the regulators removed. B. Transporting cylinders in an upright position with caps on. C. Leaving the cylinders under direct sunlight for under 10 minutes. D. Securing the cart to prevent tipping during transport. Answer. Correct answer, A. Explanation. Regulators must be removed and protective valve caps installed during transport to comply with CGA P1 and OSHA 1910.253. Cylinders under sunlight are permitted briefly provided they remain below 125 degf. Upright secure transport is mandatory. Leaving regulators on poses severe rupture risk if the valve is struck. Question 9. Taking into account joint type and base metal, which filler material is best suited for brazing? A vertical joint between two aluminum HVACR fins in an evaporator, a 95-5 tin antimony solder with water-soluble flux. B. B-cup 5 phosphorus copper alloy with no flux. C. Aluminum silicon brazing rod with non-corrosive flux. D. Elo hydrogen electrode without flux. Answer. Correct answer, C. Explanation. Aluminum silicon rods e.g. Borsone paired with non-corrosive flux are optimized for brazing aluminum, especially in vertical or thin sections. Faux copper is for copper alloys only. Solder lacks strength and melting temperature for brazing. It is for small welding, not brazing. This aligns with all C.7 brazing protocols. Question 10. When analyzing fire safety compliance, technician Rosa is tasked with performing hot work inside a mechanical room. A permit is obtained and a fire watch is posted. Which extinguisher must be present and suitable for the most probable fire risk? A. Class A water extinguisher for insulation fires. B. Class C co-extinguisher for live electrical panels. C. Class D dry powder for flammable metal components. D. Class B dry chemical extinguisher for flammable liquids and gases. Answer. Correct answer, D. Explanation. HVACR hot work often involves flammable gases, e.g. acetylene and lubricants, which are Class B risks. NFPA 51 MINOSHA 29 CFR 1910.252 mandate appropriate extinguishers for anticipated fire types. Class A covers wood paper, Class C for energized panels, and Class D for rare metal fires like magnesium nut HVAC applications. Question 11. The primary reason for carefully managing heat during the welding of access ports on semi-hermetic compressors is to protect which critical component from damage during repair or retrofitting? A. Compressor shells paint coating. B. Electrical windings and internal insulation. C. External piping seals and gaskets. D. Crankshaft balancing counterweights. Answer. Correct answer. B. Explanation. Excessive heat can melt insulation and damage motor windings inside semi-hermetic compressors. Even brief overheating can short internal windings or deteriorate varnish coatings. To comply with OEA guidelines and ASHRAE standards, shielding and proper heat sinking are mandatory during port welding. External seals and crankshafts are protected internally. The internal windings remain most vulnerable. Question 12. By comparing copper and steel during HVACR pipe welding, what is the main metallurgical reason preheating is recommended more often for steel than for copper? A. Steel has higher electrical conductivity and heats faster. B. Copper melts at lower temperatures than steel. C. Copper absorbs heat rapidly and dissipates it quickly. D. Steel has lower ductility than copper under high pressure. Answer. Correct answer. C. Explanation. Copper acts as a heat sink, absorbing and dissipating heat rapidly. Steel, by contrast, retains heat and has higher thermal resistance, making it more prone to cracking under localized heating without preheat. Preheating steel minimizes thermal shock, and hardening in the heat-affected zone has PAROS D.12 and ASM section Roman Elding codes. Question 13. In light of recent developments, technician Zoya is instructed to weld 2-inch schedule 80 steel using small. She selects the electrodes but finds difficulty striking and maintaining an arc. What is the most likely cause of the issue? A. Using descent polarity instead of decep. B. Rod stored in a rod oven at 350°. C. Pipe surface not cleaned at mill scale. D. Welding with excessive amperage for rod size. Answer. Correct answer. A. Explanation. The electrodes require decep reverse polarity. Using descent leads to arc instability, poor penetration, and frequent arc outages. Despite proper rod storage and cleaning, the wrong polarity causes the biggest arc control issue. PAROSA Point 1 and manufacturer guidelines. ES flux chemistry depends on reverse polarity for proper arc ignition and fusion. Question 14. Throughout the course of a welding project involving various metals, technician Daniel must choose an electrode for vertical welding of galvanized steel conduit. What electrode is best suited for reducing porosity and minimizing spatter in this scenario? A. Cellulose-based electrode. B. Rutile electrode. C. Low hydrogen electrode. D. Fast freeze electrode. Answer. Correct answer. B. Explanation. With its rutile-based flux provides smooth arc starts and low spatter, ideal for galvanized steel where fume control and porosity are concerns. Any are better for deep penetration but may worsen zinc vapor porosity. E is low hydrogen but doesn't handle zinc fumes as well. Refer to as D.3 and zinc-coated steel welding guides. Question 15. The evolution of HVAC system complexity has led to diversified welding demands. Which type of HVAC system installation is most likely to require both aluminum and copper brazing procedures within the same project? A. Packaged rooftop units with scroll compressors. B. Water source heat pumps in a closed loop. C. Multi-spit ERF systems using inverter compressors. D. Ground source geothermal loop systems. Answer. Correct answer. C. Explanation. Variable refrigerant flow (VRF) systems often include aluminum microchannel coils and copper refrigerant lines, especially in inverter-based systems. This demands specialized brazing techniques and dissimilar metal handling. Rooftop units and water source systems usually involve copper or steel only. Refer to manufacturer specs and ASHRAE handbook. HVAC systems and equipment. Question 16. From the perspective of safety and structural integrity, what is the best method to ensure uniform capillary action and minimal oxidation when brazing copper tubing with a silver phosphorus filler? A. Apply flux to both the inside and outside of the joint. B. Use nitrogen purge during brazing and cool with water spray. C. Heat the joint evenly, starting from the thicker component. D. Rotate the tubing during brazing to distribute filler evenly. Answer. Correct answer. C. Explanation. Even heating is critical for proper capillary action in brazing. The thicker component must be heated first as it takes longer to reach brazing temperature. This ensures proper filler flow toward the heat source. Nitrogen purge is important but does not influence heating distribution. OR's B-cup specs and SMACNA brazing manuals reinforce this heating principle. Question 17. In response to a report of repeated breaker trips, welding supervisor James inspects the equipment and finds unshielded leads, moisture near the machine, and inconsistent grounding. What represents the greatest immediate electrical hazard? A. Moisture accumulation around the machine base. B. Exposed conductor ends on the ground clamp. C. Loose power cord connection at the panel. D. Damaged electrode holder with arcing marks. Answer. Correct answer. A. Explanation. Moisture near electrical equipment presents a direct shock and fire hazard, especially in welding environments. According to NFPA 7 and OSHA 1910 subpart S, water near electrical current can cause arcing, equipment shorting, or electrocution. Exposed conductors and arcing are also risks, but not as immediately hazardous as moisture plus current proximity. Question 18. The interrelationship between metal properties and refrigerant types directly influences pipe selection. Which material is most suitable for high-pressure R400 TINA systems in commercial installations? A. Anneal Type M copper tubing. B. Type K hard copper with brazed joints. C. Schedule 10 black iron pipe with threaded joints. D. Galvanized steel pipe with compression fittings. Answer. Correct answer. B. Explanation. Type K hard copper has the strength and pressure rating suitable for R400 TINA systems, which often exceed 400 psi. Type M is too thin. Galvanized and black iron piping are incompatible with refrigerants and violate ASHRAE and SMACNA pressure piping standards. Joints must be brazed, not threaded or compression type, for refrigerant integrity. Question 19. While examining a large bore steel condenser pipe, technician Rog must bevel the ends before welding. He uses a mechanical beveling machine and inspects the surface. What bevel angle is typically recommended to ensure full root fusion with a groove weld? A. 15 degrees toe included angle. B. 22.5 degrees on each side, 45 degrees total. C. 30 degrees on one side with backing ring. D. 90 degree square cut with root gap. Answer. Correct answer. B. Explanation. A 45-degree total included angle, 22.5 degrees each side, is standard for groove welds per B.1 and OR's D.1, ensuring proper penetration and filler metal accommodation. This allows better weld pull control and less risk of incomplete fusion. Square cut and excessive angles compromise joint strength or require different methods. Question 20. The central argument for why technician Myers welds on vertical steel riser keep failing X-ray inspection due to internal lack of fusion lies in which most probable root cause. A. Overheating of filler metal during final pass. B. Improper electrode travel speed and angle. C. High voltage settings causing undercut. D. Use of shielding gas with incorrect flow rate. Answer. Correct answer. B. Explanation. Improper travel speed and torch angle often cause lack of sidewall fusion, especially in vertical welds where gravity and puddle control at critical. High voltage may cause undercut, but fusion relies on technique and bead placement. OR's D.1 stresses the importance of travel angle and consistent speed for complete joint fusion. Question 21. Among the various strategies used to protect workers during HVACR welding, which measure is the most effective when welding galvanized steel in a confined space with poor natural airflow? A. Wearing an end respirator mask during welding. B. Using local exhaust ventilation, LEV with fume hoods. C. Increasing amperage to reduce welding time. D. Keeping doors and windows slightly open. Answer. Correct answer. B. Explanation. Welding galvanized steel produces zinc oxide fumes, which are highly toxic. The best mitigation is local exhaust ventilation that captures fumes at the source. Per NIOSH and OSHA 29 CFR 1910.252, general ventilation is insufficient in confined spaces. Respirators help, but LEV is the primary control method in hazard hierarchies. Question 22. Focusing specifically on a mechanical blueprint, technician Sophia encounters a symbol showing a double groove weld with a backing strip required. Which feature does this symbol indicate? A. Groove weld from one side only with no backing. B. Fillet welds on both sides with full penetration. C. Weld preparation on both sides with backing bar retained. D. Intermittent weld on both sides of the joint. Answer. Correct answer. C. Explanation. A double groove weld symbol with a backing bar symbol underneath indicates full weld prep on both sides and a backing bar retained in place after welding. This ensures full penetration and mechanical strength, referred to as a 0.4. Standard symbols for welding for blueprint interpretations common in HVACR piping and pressure vessels. Question 23. Demonstrated by technician Elias while repairing a leaking suction line, the proper fillet alloy for brazing copper in refrigeration applications with service temperatures below -20 should possess which of the following characteristics? A. High phosphorus content and low melting point. B. Silver content above 15% for improved ductility. C. Tin lead base for low temperature soldering. D. Zinc based alloy with high fluidity. Answer. Correct answer. B. Explanation. For sub-zero HVACR applications, high silver brazing alloys, typically 15% plus, provide better ductility and performance at low service temperatures. Phosphorus-only rods may become brittle. Tin lead solders are for plumbing and are not HVACR compliant. This aligns with OR's B-cup alloy classifications and ASHRAE brazing best practices. Question 24. Taking into account stress distribution, which of the following statements best explains why? A groove weld is preferred over a fillet weld in high-pressure refrigerant pipe connections. A. Groove welds are faster and require less fillet. B. Groove welds support axial and radial loads better. C. Fillet welds cause more distortion in the joint. D. Fillet welds cannot be used on vertical joints. Answer. Correct answer. B. Explanation. Groove welds provide deeper penetration and stronger bonding, making them ideal for axial and radial pressure loads in HVACR systems. Fillet welds are often used for tacks or non-critical supports. Per ASM section Roman number B.5, groove welds are the standard for pressure-rated HVACR piping. Question 25. To better understand nitrogen purging during brazing, technician Karim is asked to explain its necessity. What is the primary purpose of using nitrogen inside copper tubing while brazing? A. To keep pressure constant inside the pipe. B. To prevent oxidation and formation of scale inside the pipe. C. To reduce the melting point of the fillet alloy. D. To act as a shielding gas for outside welds. Answer. Correct answer. B. Explanation. Nitrogen purging displaces oxygen inside the pipe to prevent oxidation, carbon scale, which contaminates the system and leads to compressor damage. ASHRAE assays and SMACNA guidelines stress nitrogen flow, not pressure, during brazing as a critical best practice for HVACR brazed joints. Question 26. Examining the consequences of poor arc stability, technician Selena finds a GMOR setup producing excess spatter and inconsistent arc control. The wire feed speed and voltage appear correct. What else should she check next? A. Shielding gas purity and flow rate. B. Ground clamp location. C. Drive roll tension. D. Contact tip size and alignment. Answer. Correct answer. A. Explanation. If voltage and wire speed are correct, poor gas shielding due to low flow, contamination, or leaks often causes arc instability and spatter. GMOR depends on consistent argon or mixed gas coverage. According to ORS D.3 and GMOR setup standards, gas shielding issues are the most common non-mechanical causes of erratic arcs. Question 27. During the process of qualifying new welders, an HVACR foreman assigns overhead welds on a horizontal steel refrigerant header. Which of the following challenges is most specific to overhead welding position? A. Gravity causes slag to settle inside the root pass. B. The arc tends to extinguish prematurely. C. Weld puddle control becomes more difficult due to drooping. D. Electrodes can only be run downhill for control. Answer. Correct answer, C. Explanation. In overhead welding, the weld puddle is fighting gravity, making control extremely difficult. Molds and filler tends to drip or sag, increasing the risk of defects. Proper travel speed, angle, and current are essential. Ors D.1 outlines welding position challenges and procedural adjustments for overhead welds. Question 20. The prevailing attitude toward temperature control in welding is rooted in understanding how metals behave under thermal load. Why is heat input particularly critical when welding thin-wall aluminum evaporator lines? A. Aluminum loses ductility and becomes brittle when overheated. B. Excessive heat causes hydrogen absorption and porosity. C. Thin-walled aluminum softens and sags easily during welding. D. Aluminum reacts with CO and produces flammable gases. Answer. Correct answer, C. Explanation. Thin-walled aluminum conducts heat rapidly and has low structural rigidity, making it prone to sagging, distortion, or burnt through with even moderate overheating. Precise amperage control is required. Ors DD.2 and Aluminum Association. GTOR techniques must be adapted to protect geometry and prevent porosity. Question 29. A critical examination of weld detail drawings reveals a welding symbol with an arrow pointing to a joint and a circle around the weld symbol. What does the circle indicate according to Ors standards? A. Weld all around the joint. B. Weld on site, field weld. C. Weld both sides of the joint. D. Weld with continuous beads only. Answer. Correct answer, A. Explanation. A circle around a weld symbol means weld all around, applicable to joints like nozzles or circular pipe fittings. It ensures 300 six-sided fusion. Per Ors 0.4, it communicates that the joint must be completely sealed along its entire periphery, critical for pressurized HVACR piping. Question 30. Historically speaking, technician Jonah attempts to TIG weld a 1/8-inch aluminum HVAC component using a pure tungsten electrode. He finds arc instability and difficulty starting the weld. What is likely the root cause? A. Use of AC current with pure tungsten. B. Use of descent instead of AC. C. Use of helium shielding gas. D. Too short an electrode stick out. Answer. Correct answer, B. Explanation. Aluminum require AC current during TIG welding to enable cleaning action that removes oxides. Using descent results in arc instability and oxide buildup. Pure tungsten works with AC but not descent. Refer to Ors D.2 in welding machine manuals for correct settings based on metal type.